Hello, students. Today we are on day 20 and we are multiplying together polynomials. Last block, what we talked about was adding and subtracting our polynomials and actually just what a polynomial was. But today we're going to be multiplying. So let's jump into it. What we'll be doing today is we'll be distributing a monomial to each term in the polynomial. I'll talk more about that as I actually do an example. When we distribute, we're going to multiply the coefficients of each term. So we're going to multiply our coefficients. And we're also going to add our exponents. So those are kind of the principles of what we're doing today. We're distributing, and when we distribute, we multiply the coefficients and we add the exponents. So let's take a look at actually an example of what this is going to look like. So the first one I've got here, I'm going to distribute in an 8. Again, when I distribute, what I'm doing is I'm multiplying. So 8 times 7 is 56. That's 56x. And 8 times -3 is -24. So once I distribute, just like that, I check to see if I have any like terms, which is something we talked about last time. And in this case, I do not. So this would be my final answer. Simple as that. From last block, we talked a lot about naming our polynomials. I would call this a linear binomial. Let's take a look at another example, this time where we distribute a negative. So I distribute a negative 2, and I get -2 times -y is positive 2y. -2 times positive 10 is -20. I check to see if I have any like terms. I don't. I'm going to box my answer. Again, that's another linear binomial. So on the next one, I'm going to distribute something a little bit trickier. I'm going to distribute a -3x. -3x times 4 is -12x. And -3x times 9x is -27x squared. Now let's just talk about that for a little bit. So I multiplied the -3 and the +9, and I got -27. And then I multiplied x by x, and I got x squared. And again, the reason for that is x times x is actually x to the first and x to the first, and I add those exponents to get x squared. Going back to what we discussed last block, I've got -12x minus 27x squared. I want it in standard form, so I'm going to switch those around to get -27x squared minus 12x. Those are not like terms, so I'm going to go ahead and box my answer. This is a quadratic binomial. Let's look at another example here. Again, every one of these questions, we're making it a little bit trickier. The concept is always the same though. So on this next one, we're going to distribute a 6. And when I do that, I get 66x squared minus 6x plus 12. And then I still have plus x squared minus 4. It actually looked a lot scarier than it actually is. So I'm going to go ahead and underline my like terms. This is a like term with this. I'm going to go ahead and combine my like terms. That is going to be 67x squared. Oh, I found another pair of like terms actually. This and this, those are also like terms. So I've got positive 12 minus 4 is positive 8. And I've also got minus 6x. Now notice I actually, as I wrote that down, I was like, oh, I didn't put it in standard form. So let's go ahead and switch it around. 67x squared minus 6x plus 8 would be my final answer for that when it's in standard form. As a reminder of what standard form is, it has to go from largest exponent down to smallest. And our constant is always at the end. That would be called a quadratic trinomial. All right, so I hope you guys are catching on to this. Let's continue with a few more examples here. So I've got 5m squared plus 4 minus m times 10 minus 2m minus 13. So whatever is outside of my parentheses right here, that's what I'm going to distribute in. So I've got 5m squared plus 4, and I distribute in a minus m, or negative m. I get minus 10m plus 2m squared. Again, negative m times negative 2m is positive 2m squared. And then the minus 13, that's not in my parentheses, so that's just still at the end over there. Let's go ahead and combine like terms. Let's see, I've got 5m squared and 2m squared, and I've got 4 and negative 13. So let's go ahead and combine those like terms. Let's go ahead and simplify it. I've got 7m squared minus 10m. 4 minus 13 is minus 9. And notice that time I did write in standard form. That is a quadratic trinomial. Continuing along, let's do something with fractions. I always say fractions are friends. Don't be scared because there's a fraction in there. In high school, when you guys start getting into upper level mathematics, you really need to get comfortable with those fractions. So let's just kind of practice a little bit here. We distribute in a half, and we distribute in a negative. I knew to do that because whatever's next to the parentheses to the left gets distributed in. So I've got 1/2 times 11. I do not want you to change this to a decimal. Keep it as a fraction. 11 over 2x squared. 1/2 times negative x is negative 1/2 x, and 1/2 times 2 is 1. Then I've got plus x squared, and then I'm going to distribute in a negative. So minus x plus 1. All right, so again, don't let those fractions freak you out. We're going to combine like terms. This and this, this and this. Now, I've got 11 halves, and I want to add that to 1x squared. So if we want to talk about fractions for a second, I need a common denominator to add. So this is actually 2 over 2x squared. And this is actually 2 over 2x. I got a common denominator with its like term. So I'm going to combine like terms, and I get 11 halves plus 2 halves is 13 halves x squared. Negative 1/2 x minus 2 halves x is negative 3 halves x. And 1 plus 1 is 2. So again, check to see if you have any more like terms in your answer. If I don't, and I'm in standard form, which I am, I'm going to go ahead and box this up and call that a quadratic trinomial. All right. So hopefully you guys are getting the hang of this. If you're ready, you can go ahead and pause the video and try those next two out. And then I'll go over the answers. So pause the video, try them out, and then check them as I work them out. So here we go. Those try them out questions, let's distribute. I'm going to pick up the pace a little bit here. So 2 times negative 8x squared is negative 16x squared. And 2 times 2x is 4x. 2 times 9 is 18 plus 3x. I've got a like term with a like term, and my answer would be negative 16x squared plus 7x plus 18. That would be a quadratic trinomial. And the second try it out question over here, I distribute in my negative, and I get 12 plus 8h minus 4h squared minus 12 minus h. Combining like terms, this goes with this goes with this, and I'm left with negative 4h squared plus 7h. These cancel out. So that would be my final answer, and that is a quadratic binomial. Hopefully you got those two correct. Okay, so in each one of those, what we did is we distributed in a monomial. We were only distributing in one term. So we're going to shift gears and talk about how we multiply binomials together. So binomials, the prefix bi meaning two. So we're going to multiply two binomials together. I can either use what we call the FOIL method or the box method. FOIL is an acronym. So I can either use either one of these methods. And I'm going to show you guys both. My preference and most of the Westwood teachers is FOIL. However, if the box method helps you with the visual, you're welcome to use the box method as well. Usually when you see me work these out, I'm going to be using the FOIL method. But if the box works for you, I say go for it. So the FOIL method, what it means is we multiply together the first terms in each binomial. So let me zoom in a little bit here. We multiply the first terms, which would be this and this. So I'm going to draw an arrow from there to there. Those are the first terms. So x times x is x squared. Then we multiply our outside terms. Let me switch colors, actually. Let's go with this color. We multiply the outside terms. Outside, outside. And when I multiply my outside terms, I get minus 2x. Then, let me switch colors again. I'm going to multiply the inside terms. Inside, inside. And let's draw an arrow there. When I multiply my inside terms, I get plus x. And then I multiply my last terms. Last. 1 times negative 2 is negative 2. That's the FOIL method. Oh, I guess I could connect those. So, and again, I'm going to practice this more, but I look at the first terms and I multiply them together. Outside terms, I multiply them. Inside terms, I multiply. Last terms, I multiply. And then I combine like terms. So I've got x squared. These two are like terms. That's minus x, minus 2. And that is how you multiply together two binomials. That was the FOIL method. Now I'm going to show you the box method. As the name implies, there's a box. So So I'm going to draw my box. And on one side of my box, I'm going to put my first binomial. So I'm going to put in x right here and a 1 right there. Then I'm going to put in my second binomial across the top, x and minus 2, or negative 2. Then I'm going to split up my box into 4 quadrants. So I make my box, I label the first binomial on one side, the second binomial on the other. It doesn't matter if you put the x minus 2 down the side or the x plus 1 across the top, that doesn't make a difference. And now I'm going to multiply. So this first box, the upper left quadrant, I'm going to multiply the x times the x, and I get x squared. Then in the upper right quadrant, I multiply the x and the negative 2, and I get negative 2x. In the lower left, I multiply x and 1, and I get x. And in the lower right, I get 1 times negative 2 is negative 2. Again, the box helps us kind of organize our work and get a visual. So now I look at how to combine like terms within my box. And notice, let me choose a different color here. These are both like terms. So I'll just combine those together and I get x squared minus x minus 2, which is exactly what we got when we use the FOIL method. So ultimately, you get the same answer either way by using either FOIL or by using the box method. So either way you want to go, I support both methods. They'll both get you to the same answer. That's a quadratic trinomial. All right, so again, I'm going to practice both again with you so you guys can see them both again, but my preference is FOIL. So once I practice both of you, I'm going to switch back over to using FOIL because that's my personal preference. But if yours is the box, go for it. So the first one I'm going to practice over here, I'm going to do FOIL on it. And oops, and I'm going to do first terms, then outside terms, then inside terms, then last terms. With the FOIL method, you're basically multiplying everything by something else. So what I mean by that is I'm multiplying the x by the x and the x by the negative 4. Then I'm multiplying the 3 by the x and the 3 times the negative 4. So x times x is x squared. X times negative 4 is negative 4x. 3 times x is positive 3x. And 3 times negative 4 is negative 12. So sometimes students think of this as like double distribution. I'm distributing in the x, and then I distribute in the 3. And then, of course, we look for our like terms. And I get x squared minus 4x minus 12. My answer is in standard form. Oops, I actually just made a mistake. As I looked back at that, I was like, what are you doing? It's minus 1x, y'all. Whoops, minus 4x plus 3, that's minus 1. Whoopsies. All right, so let's go to another one. We'll do the box method on this one. So I draw my box. I'm going to put the x and the 2 up top and the 2x and the 1 right there. So 2x squared, let me zoom in a little bit. 2x squared times x, or excuse me, 2x times x is 2x squared. 2x times 2 is 4x. 1 times x is x, and 1 times 2 is 2. I look for like terms in the box, these two, and I combine those together. I get 2x squared plus 5x plus 2. That's another quadratic trinomial. All right, so hopefully you guys are getting the hang of this. Let's go down to this next one, and I'm going to pick up the pace a little bit, and I'm going to use FOIL on it. So first, outside, inside, last. 3a times 2a is 6a squared. 3a times negative 5 is negative 15a. Negative 8 times 2a is negative 16a. Negative 8 times negative 5 is positive 40. Combining like terms, I get 6a squared minus 31a plus 40. That, again, is written in standard form for a quadratic trinomial. I want you guys to practice those fractions. So here's another one with fractions. Oops. First, outside, inside, last. X times x is x squared. X times a quarter is 1/4 x. 1/2 times x is 1/2 x. And 1/2 times a fourth is 1/8. So I've got to combine like terms here. That 1/2 is actually, if I multiply both the denominator and numerator by 2, I get 2/4. So now I can combine it together. So I get x squared. Combining those terms, I get positive 3/4 x plus an eighth. There you go. All right, so I want you guys to pause the video and try to work out those last two for me, and then unpause and check your work. Go. Okay, so on this first one, again, I'm going to pick up the pace a little bit. So we've got first, outside, inside, last. 3y squared plus 9y plus 3y plus 9. Like term, I get 3y squared plus 12y plus 9. Quadratic trinomial. And the last one over here, first, outside, inside, last. 5 times x, 5x squared. 5x times negative 2, negative 10x. 7x minus 14. Combine like terms, 5x squared minus 3x minus 14. All right. This is such an important skill, y'all. I really hope that you're getting it down. Okay. So we've multiplied a monomial by a binomial, two binomials together, and now we're just going to practice a little bit more. There's a couple more things that I want to talk to you guys about. So this next one, sometimes in mathematics, you might see something like this. And I want you guys to think about what it means to square something. So what it means to square something is to multiply it by itself. In other words, when I square this binomial, this is the same as x plus 6 times x plus 6. Literally the same thing. When I square something, I multiply it by itself. And that's perfect because you guys know how to solve this now. First, outside, inside, last, x squared plus 6x plus 6x plus 36. Combine those like terms. I get x squared plus 12x plus 36. In standard form, that's my quadratic trinomial. So same sort of deal. If you see a binomial squared, just write it out and then jump to the FOIL or box method. Same sort of deal on the second one. I'm just going to write it out real quick. So I've got 3x minus 2, 3x minus 2. First, outside, inside, last, FOIL. 3x times 3x, 9x squared. 3x times negative 2, negative 6x. Negative 6x plus 4. Combine those like terms. 9x squared minus 12x plus 4. All right. So here's something else to look out for. I want to show you guys something. This is going to come back to be something that we talk about after spring break. So let's take a look at this next one, number 3. Number 3, those look similar. Those binomials look similar, but the 3's have different signs. Negative 3, positive 3. Negative 3, positive 3. So first, outside, inside, last. X times x, x squared. X times negative 3, negative 3x. 3 times x, 3x. 3 times negative 3, negative 9. Now I want you guys to look at something for a second. My like terms will cancel out. So what I'm left with is a quadratic binomial, x squared minus 9. And this is actually something that we call a difference of squares. Oops, what's going on? Squares. It's called a difference of squares because x squared is a perfect square, meaning x times x is x squared, and 9 is a perfect square. 3 times 3 is 9. So this quadratic binomial is what we call a difference of squares. And again, this is a topic that we're going to come back to after the break. The reason why that turned into a binomial instead of a trinomial is because the 3's had opposite signs. So when we combine our like terms, the 3 and the negative 3, those canceled out and our middle term disappeared. So that's kind of a special case in math we call the difference of squares. And the next one, same sort of deal. Take a look. I've got a positive one and a negative one. That's the only difference between those binomials. First, outside, inside, last. 4x squared minus 2x plus 2x minus 1. Those terms will cancel out. And I'm left with 4x squared minus 1. Again, another difference of squares. So that is also a difference of squares. Okay, we are now entering the challenge zone, y'all. We're going to get ready to finish up this lesson. So the challenge zone. So here we go. We've got a binomial times a trinomial. Same concept, except we can't use FOIL because we've got a trinomial instead. So it doesn't apply anymore. But I'm going to basically show you guys how to do the distribution with a trinomial instead. So let's zoom in a little bit. I'm going to multiply my 2x times my first term, my 2x times my second term, and my 2x times my third term. Then I'm going to multiply my negative 3 times my first term, my negative 3 times my second term, and my negative 3 times my third term. So it looks scary, but the process is still the same. Let's go through it together. So 2x times x squared is 2x cubed. Remember, add those exponents. 2x cubed. 2x times 2x is 4x squared. 2x times minus 5 is negative 10x. Now we multiply in or distribute in the negative 3. Negative 3x squared minus 6x plus 15. I distributed in the 2x, and then I distributed in the negative 3. And I get, after I look for like terms here, like term, like term, like term, like term, let's see. I get 2x cubed plus 1x squared minus 16x plus 15. That I would call a cubic polynomial. I'm just calling it a polynomial because it has more than 3 terms. So that would be a cubic polynomial. Cubic polynomial. Okay. See, that wasn't so bad. Last but not least, let's finish it off with a little geometry thrown in. So I want to find the area of a square with a side length of 4x minus 3 inches. Let's draw ourselves a square. Pretend that's a good looking square, y'all. And I've got 4x minus 3 on the top. And since it's a square, all 4 sides are equal. So all 4 sides are 4x minus 3. Now, if you think about it, area of a square is side squared. And we know how to do this because that's going to mean 4x minus 3 is squared. So we're going to go back to what we did up top here. We're going to say area equals 4x minus 3 times itself. That's what I get when I square something. And I'm going to do first, outside, inside, last. Let's finish it off. 16x squared minus 12x minus 12x plus 9. Combine those like terms. I get 16x squared minus 24x plus 9. And that's going to be in inches squared because I'm talking about area. There we go. All right, y'all, that was your lesson on multiplying together polynomials. I hope that made sense to you. Of course, next block is a review block, so I will answer any and all of your questions next block. Have a good day.